Hi, so in this video what we're going to have a look at is adding and subtracting sinusoidal waveforms. Now we're going to use three waveforms, 8 sine omega t, 3 sine omega t, and then 8 sine omega t minus pi by 6. Now the first thing I'm going to show you is how we can input these into Excel. So the first one, for example, 8 sine omega t. So equals 8 asterisk for multiply sine open brackets. Now because what I've got on the left hand side here are values in degrees, which are more familiar to us but not terribly useful for this equation, we need it in radians, I'm going to type out radians open bracket, then show it where the cell is. It's A3, close a couple of brackets, and that will show that. Now I've also formatted all of these to show the angle, if I click format cells, as a number to 1 decimal place. Now all I have to do to replicate V1 formula is highlight the cell I've now completed, go to the bottom right hand corner, hold the left mouse button when I've got that symbol, that plus symbol, drag it all the way down to the 360, release it, and it will populate it. You can see I've already in advance created graphs for all of these things as well. So V1 is the blue waveform in each case. Now for V2, what I'm going to do first of all is type this one out as well. Now this is very similar because the only thing I'm changing here is the amplitude. So equals this time 3 asterisk, don't forget that, sine open brackets radians open brackets again A3, close a couple of brackets. That puts that one in, and then the same thing to replicate down, and the orange one is V2. Now if I have a look at this first of all, I'm just going to make this graph larger for now just so that we can see this. Oh yes, very good. Let's get rid of these. So what we can see is all the difference was that the amplitude of V2 was smaller. Amplitude of 3 means that when it reaches a peak, which both of them do at 90 degrees, V1 has an amplitude of 8, so it reaches a peak of 8. V2 has an amplitude of 3, so it reaches at a peak of 3. And then each of them goes -8 to -3 respectively. But it's all at the same point. They both hit 0 at the same point on the x-axis, both have their peak at the same point on the x-axis, both pass back through 0 at the same point, 180 degrees, and both hit their troughs at 270 degrees at both at the same time. Now what I'm going to do for V3 is to introduce a phase shift. So I'm going to basically copy the V1 formula, but this time instead of it just being 8 sine omega t, it's going to be 8 sine omega t minus pi by 6, which is a 30-degree angle. So equals 8 asterisk sine open brackets radians again, still point it to the cell where we're starting off here, so that's A3, close brackets, then minus open brackets. Now pi open bracket close bracket, because pi on its own Excel doesn't know you want to use pi, so it's pi open bracket close bracket, divide by 6, close your brackets off again, and of course I've missed off a bracket. Excel's clever, it knows what I'm trying to do. Hold that cell, bottom right hand corner, to replicate that down as well. So now we've got all three waveforms. We've got the blue one, which is V1, the orange one, which is V2 and is the same as V1 except it has a lower amplitude, and then V3 is again the same as V1 except this time instead of the amplitude being changed, I've given it a phase shift. Everything is, you could superimpose V1 and V3 absolutely perfectly. I've just shifted everything 30 degrees along the x-axis. If I look here, for example, V3 first hits the x-axis at y equals 0 at 30 degrees. It hits its peak at 120 degrees, which is 30 degrees later than V1. Same thing with the trough, it hits that at 300 degrees, 30 degrees after the 270 for V1. So that's how you vary the waveforms. The first number before the sine is just the amplitude. The larger that number, the greater the peaks and the troughs. Inside the brackets, if we add or subtract anything to the omega t, then we're going to introduce a phase shift, which just shifts it along the x-axis. So now in terms of adding and subtracting, this one should be fairly straightforward. I'm just going to make this graph a little smaller and to bring my other ones back up. So what I'm going to do first of all, in fact I'll put that one down there for now. So I'll already make this a little bit larger so that we can see it nice and clearly, because we're going to add and subtract V1 and V2. Now I'm just going to add to begin with. So V1 plus V2, nice and easy, it's just equals, there's the V1 plus there's the V2, done. For the subtraction equals the V1 minus the V2, that's that one done. Now I'm just going to do one at a time, so I'm just going to replicate the V1 plus V2 to begin with, and that brings this up in grey. So what you can see is literally at each point along the x-axis we've just added up what is the y value of V1 and V2 together. So for example, at 0 they're all 0. At the peak of V1, the blue line, was 8. The peak of the orange line was 3. 8 plus 3 is 11, and the grey one peaks at 11, and then troughs at minus 11. So all we're doing is adding them up. It's the peaks coincide, the zeros coincide, the troughs coincide. That one's fairly straightforward. So now what I'm going to do is I'm going to show the V1 minus V2 as well. So this is in yellow. And in this case, because it's a subtraction, again, the peaks still follow, the zeros still follow, and so on. But you can see that it is between V1 and V2. For example, at the peak, we are doing 8 minus 3 to get 5. It peaks at 5, it troughs at minus 5. So this one, hopefully, fairly straightforward. So I'm just going to get rid of this now. And then we're going to bring V1 and V3 up. Again, make it nice and large to begin with. So this one, remember, doesn't have an amplitude change, just a phase shift. So again, V1 plus V3 equals the V1 cell plus the V3 cell. And the subtraction is, actually we'll just do the plus to begin with again. So highlight that down. So in grey we've got V1 plus V3. So notice here that the peak no longer coincides. In fact, the peak is between the peaks of V1 and V3. Same with the trough there, because we have that phase shift. In addition, we are still adding it, so the peak at V1 plus V3 is greater than V1 and V3. Now if I do the subtraction one, V1 minus V3, and then copy this down, whoops, then this is the one in yellow. Again, we can see that phase shift, so peaks are not coinciding, troughs are not coinciding, but also now this is falling below V1 and V3 because again we have subtracted. And that's how you can use Excel to work out what the waveforms would look like. Give it a go in the practice task yourself.